Good morning to one and all. As a part of our online classes today, we are going to discuss excretion lesson. Let us see what is the meaning of excretion. In that word, we can find out the meaning of excretion. X. What is the meaning of X? Out. Excretion. The process of sending. Here, what is the meaning of excretion? The process of elimination of waste material from our body to the outside is called as excretion. Here, let us see what is the importance of excretion in our body. Let us see with an example. Here, we do observe the production of waste materials during the manufacturing of goods or any objects. Whenever we do observe these waste materials are produced during the manufacturing of items, so what happens? It's somewhat difficult to get a new item. So that's what these wastes must be eliminated from the particular place. In the same manner, in our body also, it's a place for several actions, reactions, metabolic process, metabolic activities are going on in our body. So at that time, we do observe the formation of so many waste materials. So these must be eliminated from our body. If they are eliminated, what happens? Leads to formation of so many poisonous substances. So that must be eliminated from our body. Let us see how excretion is going on in human beings. Actually, in our lesson, means in this fourth lesson, we are going to discuss how excretion is going on in human beings, as well as we do discuss dialysis process and excretion in plants also we will discuss, and we will look about the excretory organs in different organisms. In that, first of all, we are going to discuss excretory system in human beings. What are playing main role in human beings for the sake of excretion? Kidneys, everybody knows that. Let us see the location of kidneys, the size of kidneys, function of kidneys. So, human kidneys are located backside of our body or on either side of the vertebral column. Isn't it? So, here there are a pair of kidneys. The shape of kidneys are bean, in Telugu bean, chikkudu, and size of kidney is in the length 10 centimeters, in the breadth 5 to 6 centimeters, and moreover it has 4 centimeter thickness. Actually, as it is in the shape of bean, outer part is known as convex shape. Outer part is in the shape of convex and inner part is in the shape of concave. So outer zone is called cortex and inner zone is called medulla. So let us see the colors of these zones. And outer cortex is in dark colored part and the inner part is light colored. Yes, let us see human kidneys. Here, as we discussed here, there is a pair of kidneys present in our body. So here, whenever we do observe the structure of kidneys, we do observe first of all a pair of kidney, as well as every kidney has a fissure or pilus. So what do we observe at the pilus or fissure? We do observe the entry of renal artery and the exit of renal vein. Actually, what is going on inside the kidneys? The waste products of our body which are produced during metabolic process are filtered in the kidneys. Actually, inside the kidney we do observe number of millions of nephrons, around 1.2 to 1.8 millions nephrons are present in each kidney. Actually, that's what kidney, what is the structural functional unit of the kidney is nephron, as it is made up of several millions of nephrons. So it is considered as a structural as well as functional unit of kidney. Let us see the structure of nephron. Here we do observe in previously we discussed that there is an entry of renal artery in each kidney at the fissure or hilus. So what happens to the renal artery after the entry into the kidney? It has to enter into the nephron. How it enters into the nephron? Actually, soon after entry into the each kidney, divides and redivides and enters into each nephron. Actually, nephrons are present many, around 1.3 to 1.8. So, here what's going on in the nephron? Filtration is going on inside, and function is going on inside the kidney, inside the nephron. We call nephron as a structural functional unit of each kidney. So we are discussing that how already we discussed how renal artery enters into the kidney at fissura hilus. Later it divides and redivides, and after that finally it enters into the each nephron as an afferent arteriole. So actually here one thing you have to understand. So in each nephron we do observe two parts. One is cup part and another one is tubule part. So cup part Bowman's capsule. Actually, so it is made up of squamous epithelium and having so many pores, which is known as podocyte cells. Podocyte cells is made up of podocyte cells. Here we have to observe how afferent arteriole changes inside the Bowman's capsule. One thing you have to understand here, Bowman's capsule plus I said no, here afferent arteriole divides and redivides inside the Bowman's capsule and forms a bunch of blood capillaries inside the Bowman's capsule, which is called as glomerulus. Yes, listen to me carefully here. So inside the Bowman's capsule we do observe division of afferent arteriole and division, redivision, again it divides into a lot. So finally it forms a bunch of capillaries, blood capillaries, which is called as glomerulus. Yes, that Bowman's capsule plus glomerulus together known as Malpighian body. Okay, so what I am saying here, so here afferent arteriole entered into the Bowman's capsule. Here afferent arteriole entered into the Bowman's capsule and came out as afferent arteriole. One thing you have to observe carefully here, afferent arteriole diameter is broader than afferent arteriole. Here, what is the necessity of having such kind of structural difference? Let us see. Here, as it is narrower, it is exerting pressure inside the Bowman's capsule, which leads to filtration of blood. So here, why? Because renal artery brings the blood from all the body parts and enter into the each nephron, which are present many in each kidney. So what is going on inside the nephron? Filtration is going on. Where? That too in the part of nephron. What is that part of nephron? Bowman's capsule, that Malpighian body. Here filtration rate is going on inside the Bowman's capsule. Here, let us observe what's happening Bowman's capsule. Here, what is happening here? Inside the cup part, filtration is going on. So at the time, the blood is filtered and entered into the tubule part, which is considered as which is called as primary convolutions tubule, PCT. One thing you have to understand, what is meant by convolutions? Why we have to call it as PCT? Let us discuss. Here, as I said before, Bowman nephron consists of mainly two parts. One is cup part and another one is tubule part. Cup part is known as Bowman's capsule. Inside the Bowman capsule, bunch of blood capillaries, that is called glomerulus. Bowman's capsule plus glomerulus together known as Malpighian body. And next tubule part we do observe first some convolutions. They are at the starting, that's what is called as primary convoluted tubule. Convolutions means now curves. So that is called PCT. Later we do observe that it is in the shape of hairpin, which is U shape. That is called loop of Henle. Later we do observe some convolutions, distal convoluted tubule. Yes, this is about the structure of tubule part. So these DCT, distal convolution, and second time we do observe now convolutions. That part is called as distal convoluted tubular DCT. That opens into collecting tube. It opens into collecting tube and forms pyramid and calces. That opens into pelvis, isn't it? So that come out as ureter, isn't it? So here let us discuss how urine is passed from the kidneys, kappa to the ureter. So we have to call it as how urine is formed. It's a kind of mechanism of formation of urine. Let us discuss that mechanism of urine formation. In that mainly 4 stages we do observe. One is glomerular filtration, and second one is tubular reabsorption, and the third one is tubular secretion, and the fourth one is concentration of urine. So already we discussed how filtration is going on inside the cup part. So already we discussed afferent arteriole is broader, which enters into the cup part, that is broader than the afferent arteriole. As it narrower, it exerts pressure inside the cup part. So automatically what's happening due to the pressure, it is being pushed and pushed inside the cup part leads to filtration, which is called as ultrafiltration. So soon after glomerular filtration, we do observe the entry of that filtrate into the PCT part, which is called as primary urine. And after the completion of glomerular filtration, we do observe the formation of primary urine. It enters into the PCT. Okay, now actually in that primary urine, it is almost whatever components are present in the blood, same components are present in the primary urine except some blood cells. 90% same. So what happens if it is so? All the essential ions, minerals will be lost. If it is excreted to outside, then what to be done? It has to be the essential minerals and ions to be reabsorbed. As it is going on in the PCT region. Where it is going on? PCT region. Tubular reabsorption. Excess water and necessary ions and minerals are reabsorbed into PCT. And some little amount water also absorbed and other tubule part. Okay, that is about tubular reabsorption. Next, what is left over? Tubular secretion. We do observe unnecessary, means which are not useful. The kind of ions, especially potassium, sodium, these kind of ions to be eliminated from our unnecessary excess amounts to be eliminated from our body. So that to be secreted into the DCT region and come to the DCT. And finally, we do observe the formation of urine. It is concentrated because all the excessive water and essential minerals and ions are reabsorbed, and unnecessary waste materials and ions secreted into the tubular region. So total that is collected into the collecting tubule and forms pyramid and calces, open into the pelvis and comes out as ureter. Now that urine is passing through the ureter, which is second part, ureter, and comes into the urinary bladder. It has a capacity of 300 to 800 ml. So later we do observe the structure of urethra. It is different in female as well as male. It is 4 cm long in female, 20 cm long in male. So in such way that filtered urine is passed from the kidneys to the ureter, from ureter to urinary bladder, from urinary bladder to urethra and comes out. which is called as micturition. Yes, this is about the process of blood filtration and excretion, process of excretion in human beings. One more thing I would like to remind you here. Right kidney is somewhat lower than the left kidney. Do you know why? Here we do observe the presence of liver. That's what it is. Right kidney is lower than the left kidney. Thank you. Here, one thing is left over, that is concentration of urine. As I said before, so concentration of urine is done by the reabsorption. So we do observe 70% of reabsorption in PCD region. Remaining 10% is done in DCD region, and another further concentration is going on by a hormone which is called as antidiuretic hormone known as vasopressin. It helps in the absorption of excess water, isn't it? So it maintains the ants level, water levels, especially in the tubular part. Vasopressin helps. That's what it is called as antidiuretic hormone. And one more thing I would like to remind you, here we discussed the entry of renal artery into the kidney and the exit of renal vein. Here at the region of tubular region we do observe the capillary network of blood capillary network. So it comes and joins and form and comes out, and means it comes out outside as renal vein. Once again I would like to repeat. Here at the tubular region we do observe capillaries of blood. So these capillaries of blood vessels join together and comes out as renal vein. So this is the exit of renal vein from the kidney. So this is the mechanism, this is the structure and the mechanism of structure of the kidney and mechanism of the urine formation. Okay.